We have studied the linear velocity in semester 1 and we have earlier studied the relation of angular velocity. But now we will find out the scalar relation between these two quantities, and for that I am again consider the motion of rigid body. So here I have considered again the same motion of rigid body in which the particle P travels a linear distance Pp dash, because this is the linear displacement. Not any angle is required to make such distance or displacement Pp dash, and the time interval is given by delta t. Also, if you remember the definition of average speed, we can now consider bracket V is equals to the arc Tt dash, that is the linear distance divided by the time interval, and here the time interval is delta t. Now suppose in this circular motion the radius of the circular path is small r. Then I can define its arc as Pp dash is equals to r into delta theta, because radius into the displacement. So see, there is a change in the angle as delta theta, and the radius we have considered as small r. So now I can substitute this value in equation number 1. So from equation 1 and 2, the average velocity v is equals to r into delta theta divided by the time interval delta t. Now if you remember, this delta theta over delta t is nothing but the angular velocity or angular speed. So I can directly write r bracket omega. So this is the generalized equation for the scalar relation. But before that, this bracket is suggest for average, but we have to find out the general relation. So I am taking the instantaneous linear velocity for instantaneous linear velocity v is equals to v now, because the instantaneous. Here also limit delta t tends to 0 I have to apply, and on the right hand side also limit delta t tends to 0 r delta theta over delta t. So r d theta by dt, and therefore the left hand side is v, and this is the simple omega. So this is, we can say, the actual scalar relation between linear velocity, means this is the linear velocity, and the angular velocity of a rigid body. So now after deriving the scalar relation, now we will do the vector relation between angular velocity and linear velocity. Vector relation between angular and linear velocity, for which again we will consider the motion of rigid body. Here the motion of the rigid body is shown, in which the situation of the position vector r, means OP, and it moves, or we can say the particle p is moving with the linear velocity v, and this particle p is moving with the condition that satisfy for rotational motion, and you can see clearly the direction of omega, means the direction of angular velocity. So we have to determine the relation between these two quantities, means linear velocity and angular velocity. But before that, you have determined the direction. Are determined with the help of right hand screw rule. Now if you consider that the linear velocity is a vector quantity, and in circular motion the direction of this linear velocity is according to the right hand screw rule, but actually its direction is along the tangent drawn at the point. So the direction of V was actually determined with this equation. Now we have determined one scalar relation for linear velocity and angular velocity. So I am just recalling the scalar relation for linear velocity v and the angular velocity omega was given by v is equals to r into omega. But here we have to consider the vector quantities of this position vector and the angular velocity, and that are given by the vector notation r and the vector notation w or omega. So this fact is suggesting us that we have to take a product of these two vector quantities in such a way that the product should give us a vector quantity. So, which kind of relation you are going to use? So, if you use the scalar product of two vectors, means a dot product suppose you are using, then this dot product will give you a scalar quantity. But if you multiply these two quantities by cross product, then this product will give you a result in vector quantity, and so this velocity will now come into the vector form, and so our final relation or the vector relation for v and omega is vector v is equals to vector r cross vector omega. But here one thing you should have to consider that when this cross product is neglected, then you can write this as a simple form of r omega sine theta, where theta is the angle between vector r and vector omega. Now suppose if this vector or this theta is having the value of 90, then your vector v is only have magnitude, because the final answer will be r omega, and that is the simple velocity. So this way you can get only the magnitude of velocity, in which the direction you will not get, but the direction of this linear velocity you can provide by right hand screw rule. So in the physics, this is the importance that every question has its answer. Now, after discussing the velocity, what should be our next criteria? That we have to find out the velocity in particular time interval, and for that we have the quantity of angular acceleration.